What is statistics? Does listening to music while studying help or hinder learning? If an athlete fails a drug test, how sure can we be that she took a banned substance? Does having a pet help people live longer? How well do SAT scores predict college success? Do most people recycle? Which of two diets will help obese children lose more weight and keep it off? Can a new drug help people quit smoking? How strong is the evidence for global warming? These are just a few of the questions that statistics can help answer. But what is statistics, and why should you study it? Statistics is the science of learning from data. Data are usually numbers, but they are not just numbers. Data are numbers with a context. The number 10.5, for example, carries no information by itself. But if we hear that a family friend's new baby weighed 10.5 pounds at birth, we congratulate her on the healthy size of the child. The context engages our knowledge about the world and allows us to make judgments. We know that a baby weighing 10.5 pounds is quite large, and that a human baby is unlikely to weigh 10.5 ounces or 10.5 kilograms. The context makes the number meaningful. In your lifetime, you will be bombarded with data and statistical information. Poll results, television ratings, music sales, gas prices, unemployment rates, medical study outcomes, and standardized test scores are discussed daily in the media. Using data effectively is a large and growing part of most professions. A solid understanding of statistics will enable you to make sound, data-based predictions, decisions, and conclusions in your career and everyday life. Data beat personal experiences. It is tempting to base conclusions on your own experiences or the experiences of those you know. But our experiences may not be typical. In fact, the incidents that stick in our memory are often the unusual ones. Do cell phones cause brain cancer? Italian businessman Innocente Marcolini developed a brain tumor at age 60. He also talked on a cellular phone up to 6 hours per day for 12 years as part of his job. Mr. Marcolini's physician suggested that the brain tumor may have been caused by cell phone use. So, Mr. Marcolini decided to file suit in the Italian court system. A court ruled in his favor in October 2012. Several statistical studies have investigated the link between cell phone use and brain cancer. One of the largest was conducted by the Danish Cancer Society. Over 350,000 residents of Denmark were included in the study. Researchers compared the brain cancer rate for the cell phone users with the rate in the general population. The result? No statistical difference in brain cancer rates. In fact, most studies have produced similar conclusions. In spite of the evidence, many people, like Mr. Marcolini, are still convinced that cell phones can cause brain cancer. In the public's mind, the compelling story wins every time. A statistically literate person knows better. Data are more reliable than personal experiences because they systematically describe an overall picture rather than focus on a few incidents. Where the data come from matters. Are you kidding me? The famous advice columnist Ann Landers once asked her readers, "If you had it to do over again, would you have children?" A few weeks later, her column was headlined, "70% of parents say kids not worth it." Indeed, 70% of the nearly 10,000 parents who wrote in said they would not have children if they could make the choice again. Do you believe that 70% of all parents regret having children? You shouldn't. The people who took the trouble to write to Ann Landers are not representative of all parents. Their letters showed that many of them were angry with their children. All we know from these data is that there are some unhappy parents out there. A statistically designed poll, unlike Ann Landers' appeal, targets specific people chosen in a way that gives all parents the same chance to be asked. Such a poll showed that 91% of parents would have children again. Where data come from matters a lot. If you are careless about how you get your data, you may announce 70% no when the truth is close to 90% yes. Who talks more, women or men? According to Luann Brizendine, author of The Female Brain, women say nearly 3 times as many words per day as men. Skeptical researchers devised a study to test this claim. They used electronic devices to record the talking patterns of 396 university students from Texas, Arizona, and Mexico. The device was programmed to record 30 seconds of sound every 12.5 minutes without the carrier's knowledge. What were the results? According to a published report of the study in Scientific American, men showed a slightly wider variability in words uttered. But in the end, the sexes came out just about even in the daily averages. Women at 16,215 words and men at 15,669. When asked where she got her figures, Brizendine admitted that she used unreliable sources. The most important information about any statistical study is how the data were produced. Only carefully designed studies produce results that can be trusted. Always plot your data. Yogi Berra, a famous New York Yankees baseball player, known for his unusual quotes, had this to say: "You can observe a lot just by watching." That's a motto for learning from data. A carefully chosen graph helps us describe patterns in data and identify important departures from those patterns. Do people live longer in wealthier countries? The Gapminder website, www.gapminder.org, provides loads of data on the health and well-being of the world's inhabitants. The graph below displays some data from Gapminder. The individual points represent all the world's nations for which data are available. Each point shows the income per person and life expectancy for one country, along with the region, color of point, and population, size of point. We expect people in richer countries to live longer. The overall pattern of the graph does show this, but the relationship has an interesting shape. Life expectancy rises very quickly as personal income increases and then levels off. People in very rich countries like the United States live no longer than people in poorer, but not extremely poor nations. In some less wealthy countries, people live longer than in the United States. Several other nations stand out in the graph. What's special about each of these countries? Variation is everywhere. Individuals vary. Repeated measurements on the same individual vary. Chance outcomes, like spins of a roulette wheel or tosses of a coin, vary. Almost everything varies over time. Statistics provides tools for understanding variation. Have most students cheated on a test? Researchers from the Josephson Institute were determined to find out. So they surveyed about 23,000 students from 100 randomly selected schools, both public and private nationwide. The question was, how many times have you cheated during a test at school in the past year? 51% said they had cheated at least once. If the researchers had asked the same question of all high school students, would exactly 51% have answered yes? Probably not. If the Josephson Institute had selected a different sample of about 23,000 students to respond to the survey, they would probably have gotten a different estimate. Variation is everywhere. Fortunately, statistics provides a description of how the sample results will vary in relation to the actual population percent. Based on the sampling method that this study used, we can say that the estimate of 51% is very likely to be within 1% of the true population value. That is, we can be quite confident that between 50% and 52% of all high school students would say that they have cheated on a test. Because variation is everywhere, conclusions are uncertain. Statistics gives us the tools to quantify our uncertainty, allowing for valid data-based predictions, decisions, and conclusions.